So this is going to be our last section, chapter 9, section 2. This will be on regression lines. I'll make this a little bit bigger for us to start with. So again, regression lines, we're basically going to be looking at two things here. There's going to be the scatter plot, which is going to be the data that's plotted here. So there's like 1, 2, 3, 4, 5, 6 data points. So the line of best fit is going to be this line that's going to go through the middle of the data. I'm not really good at drawing straight lines, but so we want to draw this line of best fit that kind of goes through the data. And what we're looking to do is there's these things called residuals. So what we're trying to do is keep the distance from the data point and the line to a minimum. So this distance from the point to the actual line, we're trying to keep that to a minimum. And this distance between the data point and line is called a residual. So our goal is to keep that to a minimum. So it's one thing is what we're doing in creating this line of best fit. So this line of best fit is going to be an equation of a line. And in algebra, if you recall, the equation of line is going to be this y equals mx plus b. Now on our calculator, it's actually going to be y equals ax plus b, where again, m is the slope. So remember, the slope is the change in y over the change in x. So whatever the y values are describing over whatever the x values are describing is going to be that. And then the b value is going to be what's called the y-intercept. So we're going to have that going on there. So we have those two things going on. So what we're going to do is we're going to let technology help us find the slope and the y-intercept, so we don't have to do a whole lot of math here, just using technology to do that. So let me slide this back over because we are going to use the calculator now. So what we want to do is find the equation of the regression line, or again, this is the line of the best fit for the gross domestic products and the carbon dioxide emissions. So we have this data back, we had this back in chapter 9. So we have this table here. So the first thing we want to do is just put the data into the calculator. So if we hit the stat button, number 1 is edit. Again, we're going to put this in L1 and L2. So I'm going to highlight L1, hit clear, drop down, that clears off that data. Come to the right, highlight L2, clear, drop back down. That'll clear off the data that we had there. So I'm going to enter this data into the calculator. So to do that, I'm going to go ahead and pause the video while I do that. So I now have this data entered into the calculator. So we have the GDPs in L1 and the CO2 emissions in L2. So the question was there any kind of correlation between the gross domestic product of countries and how much carbon dioxide emissions they have? So remember, if we hit zoom and number 9, that'll create a stat plot for us. And notice that you can kind of see that this does look kind of linear. So notice how as the x's are going increasing, the y values are also increasing. So this has kind of what we call a positive slope. So if the x's are increasing and the y's are increasing, this will be considered a positive slope here. So as we move into this, we want to create what's called the line of best fit. So to create the line of best fit, we hit stat and we go to calculate. And this is going to be what's called the linear regression line. So this is going to be number 4. Notice how it has ax plus b. So a is going to be the slope and the b is going to be the y-intercept. So we choose number 4. Notice I can actually change mine back to L1 and L2 here. So second L1, second L2. So I don't think anything else we need to change there. Hit enter. So notice how we have this A and this B. So in creating our regression line, we're going to have this y equals mx plus b. Now, my lab, sometimes they'll round to 2 decimal places, sometimes they'll round to 3 decimal places. So let's just round these to the slope. We're going to round it to 3 decimal places. So we had this 199 to start with. Point. And we want to round the number to the third decimal place. So I have 5, 3, 4. So I have to decide whether to keep the 4 or round it up. Since we have a 6 after that, we know that 4 has to move on up to a 5. So that's going to be 5, 3, 5. So this is going to be 5, 3, 5, then our x, plus then our y-intercept. And we'll round this to 2 decimal places. So we have this 56.0. And then I have to decide, do we keep the 3 or do we round up? So since there's a 5 after the 3, that 3 has to round up to a 4. So it's going to be 56.04. So it's going to be what's called the line of best fit. Notice how the R value here is 0.873. That means that this line could be a good predictor as we move forward. So that's how we're going to create the line of best fit, is we're actually going to use technology to do that for us. Something else for I forget here, these residuals up here. Notice that the residuals that are above the line, they're going to be considered a positive residual. The residuals that are below the line are going to be considered negative residuals. And if there was a data point on the line, then the residual would be 0. So we have that with residuals as well that I need to mention there. So those distances. So I should have mentioned that up there, but anyway, let's move on into the applications. So when it comes to applications, we're going to use the regression line as long as that R value is a good value. And what I'm going to do basically is I'm just going to draw the scatter plot. If I draw the scatter plot, if it looks like it's a good linear relationship, we're going to move forward. If it's all over the place, then it's probably not going to be a good predictor. In our homework, I didn't notice anything that was out of the ordinary. I think most of ours are going to be good predictors. So we're going to be finding the line of best fit. So I think that's the way it works there. So we're going to use the regression line to predict y values for certain x values. So again, the x values are going to be given, and we're going to use those to predict the y values. So the prediction values are only meaningful for x values that are in or close to the range. So what I mean by range is meaningful x values have to be between the lowest x value and the largest x value. So they have to be somewhere between there. So it's got to be above the lowest x value and above the lowest x value and smaller than the largest x value. Or it's got to be close to the range. So if it's not between, it's got to be really close to those endpoints. Now, the question is, what's close? So that becomes kind of a judgment call. So when we predict, we have to pick x values that are meaningful. Meaningful x values are going to be between the lowest value and the largest value, or again, close to the ends. So it's got to be this one. That's what the range is. The range is kind of the distance between the smallest value and the largest value. So again, to predict y values, we're going to substitute the x value into the line of best fit, the regression line, and we're going to calculate what's called y hat, which is going to be the y value. So this process is going to be shown in the next example. So let's see if we can do that then. So again, we have hours studying and test scores. The number of hours the non-students spent studying for a test and their scores on that test. So if you study 0 hours, your test score is 40. 2 hours, your test score is 51. So we kind of did this problem before. So what we're going to do is I'm going to pause the video and I'm going to put this data into the calculator, and we're going to go from there. So first off, though, let me just get over there. So if I hit stat, number 1 for edit, up arrow to clear, down, up arrow to clear, down, So now I've got my data cleared. Now I'm going to pause it and put some new data into our calculator. So I've got my data in. Again, the L1 is the hours spent on studying, and L2 is the actual test scores. So again, I want to look at the scatter plot to start with. So I hit zoom, number 9. It creates our scatter plot. And also how it is a nice, notice how the line of best fit is going to have to kind of go through the data. And again, I don't know if I can draw over here. Now we'll see if it'll let me draw. No, it won't let me draw over here. But notice how your line of best fit has to kind of stay close to all of the X values. So I don't want to be way underneath here. I want to kind of go through the data, but also I also want to kind of drift up through this data up here. So it's going to kind of have to kind of drift up a little bit to stay as close as possible to all the data points. So it doesn't have to pass through any actual data points. It just has to kind of go through there. We want to try to keep the distance from the line to the data points to a minimum. And that's called those residuals. So what's going to happen, though, is I'm going to let the calculator do all this. We don't have to. So to get the line of best fit, we hit Stat. We go to Calculate and choose number 4 for the linear regression line. And also I've got L1, L2, all that looks good. Hit Calculate, and that gives us our values here. So again, y equals ax plus b is going to be our line of best fit. So again, the A is the 7 point. Again, we went around to 3 decimal places. So that's going to be 7.451. Then there's going to be an X there. Plus then 37.45. Since there's that 9 after that second 4, we're going to round that up too. So we're going to round the slope to 3 decimal places. We're going to round the y-intercept to 1 decimal place. So what we want to do now is I want to actually graph this line of best fit. So on your calculator, if you hit y equals, if I can type in the 7.451x, and then plus this 37.45, if I hit graph, it will now draw the line of best fit. And still, it doesn't have to necessarily pass through any specific points. What it's trying to do is trying to keep the distance from the line to the data points to a minimum. But again, like I said, the calculator did all that for us. So that's going to be our line of best fit with our data. So the next thing we want to do is we want to make predictions. So if a student studies 3 hours, what would the test be on the score? Now, the catch is X a meaningful value? So let's set the smallest value was 0 and the largest value was 8. A meaningful value is going to be between 0 and 8, and maybe even a 9, but not much more past that. So it's got to be really close to these. Typically, we want it to be between the range values, the minimum and the maximum value. So notice that negative numbers would also be not meaningful because you can't really study a negative number of hours. So that would be a very unmeaningful number. But notice how 3 does fit between our values here. And it wasn't tested. Even if it was, we would still have to test it again with our line of best fit. So what we're going to do is we're going to let the calculator do all these calculations. So what I'm going to do is there's this table set above window. Mine's in blue. So I hit the second button, hit table set. What I want to do is change this independent variable from auto to ask. Hit enter. So this allows me to choose my input values that I want. So notice how this is part of the table. So we have to go here to where it says table above the graph, and notice how it's in blue as well. So hit second table. I don't have anything in here, so it's good to go. So if I input 3, that will actually substitute the 3 into my line of best fit. So it's actually going in there and doing 7.451 times 3, and it's adding the 37.45 for me. So if I go over here and highlight that, if there was more decimal places, it would show it, but there wasn't any more decimal places. So you do want to highlight it as well to make sure there's not any extra decimal places. So our Y value here is going to be for 3 hours, and we'll round this to the nearest whole number. So when in A, when X is equal to 3 hours, our test score was about 60. If we round to the nearest value there. So, and if we look up here, 4 hours gave me 64. So 3 hours being under 64, but close to 64 sounds reasonable. So if we want to do B is 6.5 hours, that seems reasonable because you can study 6.5 hours. That's like 6 hours and 30 minutes. So that's a meaningful value. So if I put 6.5 in for X over here, so I got to move my little cursor back over there. And if I hit 6, that'll give me 82.1. So Y would equal 82 on the test. So notice how here 6 gave me a 93, but my line of best fit 6.5 actually is going to be under that a little bit. So like I said, the data doesn't have to be exactly mirroring this, but it should be kind of close. So 6.5 hours actually only gave me an 82 this time. So when X is equal to 13, notice that 13 is way outside our data here. So it doesn't make any sense to use this because it's not going to be a really good predictor. Our predictor is only going to be within where our data points were. So since we're outside there, we really don't want to calculate this. We would say this is a not a meaningful information, not meaningful data point, since it's outside our range. D would be 4.5 hours. And notice how, again, that's within our range. So if we put 4.5 into our calculator, hit enter, it'll do that math for us. So we don't have to keep doing that outside of that. So that would give us our Y value, or our study hours would be like 71, would be our test score. Like I said, I can quit this. You can put 7.451 times 3 here and add the 37.45. That should give me that 59.803, which we rounded to 60. So we can do it outside the table if we don't want to, but it can be pretty quick to do it within the table of the calculator. So let's look at this next example. Age in hours slept. The age in years of 10 infants and the number of hours each slept in a day. So we have, 0.1. Notice how they're doing these within respect to years. So this would be some type of months, if you will. So 0.2 years. So we're not 1 year olds yet, but notice that 0.9 is getting pretty close to a 1 year old. So, when the baby's really young, we're seeing 4.25 hours, 0.2 years. So, I'm not going to convert that to months, but, a young infant, 14.3. So notice we're really not seeing much change in the data. It's almost staying constant. So babies just flat sleep when they're young. So what I want to do is put this data into the calculator, hit stat, edit. So again, I'm going to go up arrow and clear, drop down, go over, up arrow, clear, and drop down. So I'm going to pause and enter this data into the calculator. So I have data into the calculator. So the first thing I want to do is just take a look at the scatter plot. So I hit zoom, number 9. Notice that we have a looks like a decreasing line. So it looks like we have things are moving in a downward direction. So it looks like, and that, for me, we kind of know that as a person gets older, they don't require as much sleep. So as X is increasing, even for babies, the number of hours they need to sleep kind of decreases. So that's considered a negative slope there. So again, I want to go ahead and find the line of best fit. So I hit stat, go to calculate, number 4. Again, L1, L2, that's all good. Just go down to calculate. And we end up with our information we need to create the line of best fit. So Y is going to equal then this A is going to be the negative. Notice how it is a negative slope, negative 0.780. X plus then our B is going to be 14.42, I should say. Okay, so let me get that fixed there. Okay. 14.42. So let's also graph the line of best fit. So if I hit Y equals, well, before I do that though, if we go back there, stat, calculate, number 4. Let's go back to there again real quick. Notice that our value again is negative 0.95. So this tells us that this line is a good predictor. So this information should make sense. It's significant. So now if we go to hit Y equals, we can put the equation of the line of best fit in there. So if I clear that off, I have a negative 0.780x plus 14.42. Now, if I go over here and hit graph, it should draw that through there. We've got an arrow there, an error. So what do we do there? See if it doesn't like that for some reason. Graph that. Oh, I know what I did wrong. I probably put a minus sign in. I always do that. So let's turn it back on. So I bet you that was delete that off there, and let's insert a negative symbol. Yeah, see how it was really long? That means it was a minus sign. Now if I hit graph, this should work. So notice that the line of best fit does kind of go through the middle of the data. Notice it doesn't pass through a point, but what it's trying to do is minimize the distance between each point. So remember, the residual is the distance from the line to the data point. So this data point has a positive residual, but this next data point, since it's below, would have a negative residual. This one here would have a positive residual. This one's below, so it's a negative residual. Notice at this point is actually on the line, so it'd have a 0 residual, and so forth and so on as we go through there. So we have that going on. So the next thing is we want to actually do some predicting. So A says, if X is equal to 0.3 years, how many hours would that baby sleep? So again, notice how on my table set, I've got asked, that's good to go. So now if I go to the table, hit second, because the table's in blue. If I hit the delete button, I can clean those off there. So I can hit 0.3, hit enter, and that gives me 14 point. So my Y value is going to be the 14 point. And since these were all to the 10th place, let's round 1 decimal place. So 14.2. So 14.2 hours of sleep for that baby. B, we have X equals 3.9 years. Notice that our range, though, our smallest value was 0.1 and our biggest value is 0.9. 3.9 years is way out of our range, so this will be not useful or not meaningful. We didn't really test out that far, so it wouldn't be a very good predictor for that. So C, we have X is equal to 0.6. That's within our range. So if we put a 0.6 in here, that gives us 13.95. So we would actually round that to, 13.9 would have to round up. So that would be like 14.0 for that. Because that 5 would make that round on up to the next level, which would be 14. So D, we have 0.8. And notice that 0.8 is also a meaningful value because it's within our range. So if I type 0.8 into the calculator, hit enter, that'll give us 13.8. So I would equal 13.8 hours of sleep. So that would give us our information there of getting some good predictions. Like I said, you don't have to use this necessarily. You could do this by just typing it out here, negative 0.780 times 0.8 plus 14.42, hit enter. And that does give you that 13.796 or 13.8. So either way, you can do that part. But the more you get from with the calculator, just makes things a little bit easier sometimes too. Well, that concludes our lessons on linear regression.